Hello, my name is Sohail Hildebrand from Team 47874J, the Canadian Inquisition, and this is my robot explanation video. So this was the robot that we used at two competitions. One was a competition here locally in Bellingham, and one was the Ignite Signature event down in Redmond. So to start off, let's just go look at our drivetrain. Oh, let me flip it over the other way. Yeah, so our drivetrain uses 6 motors, 600 RPM direct drive. We can see that they go right in here, and we cut down 24 tooth gears in between the 60 tooth gears here. And that was to make sure all the wheels spin at the same speed, and that definitely was a huge help during autonomous. And we cut them down just to save space and weight, because with 600 RPM drive, every gram matters just that much more, and 24 tooth gears are super heavy. These high strength bars, we drilled holes in them to make our drivetrain even stronger, and this was super helpful. I would highly recommend this for any other team. Let's see what else. Our battery, we just fit down in here. We didn't have to put any a clip for it, because the cable kept it in place, and it never really came out in any of our matches. It was a little annoying to replace because we had to flip the robot up every time we did it, but I think it was a good spot and really fit snugly in there. Let's see, now flipping it back up, we have our intake. So our intake, we are using a half-watt motor, because we found out through testing that it functionally works exactly the same for half-watt or full watt, so we might as well just use that half-watt. It is sped up to 600 RPM here, and we are using rubber bands covered with foam. This helped us tremendously with grabbing tri-balls and putting them into the goal quickly, especially if our partner was match loading. This bar here, you can see we've never actually seen what's it called? Standoffs, there we go. My bad. Standoffs like bend this much, so we'll probably have to replace that with some stronger material at some point. And speaking of stuff bending, we can move on to our sleds. Our sleds, we have a sled here and a sled here. We didn't add any sleds to the back because we didn't have enough room in the 18x18. And we never really went over the backside anyways, so it didn't really matter. But you can see here we're using metal sleds, and the reason for this is that when we use plastic sleds, because our robot goes so fast, they shatter super quickly, even though we're doubling them up. So these actually worked really well. We could get over the barrier super effectively and made us a lot more maneuverable and versatile in our gameplay. And then here we have the brain. We have the brain down here. We kind of wanted the brain to help push over tri-balls, and this was probably a terrible brain placement, because one of our brains actually ended up breaking, where our autonomous would never run. This was the reason for most of our losses at Ignite, but we didn't realize it was a brain issue till the very last match, so that really didn't change too much. But in our next design, we'll probably move the brain to be more central and less exposed, and have some other thing to help push over tri-balls. Moving on, we have our wings. Our wings, we have fold-down wings. As you can see, they're a little shoddy because we went through several iterations and we kind of ran out of time close as we approached the competition. The vertical wing, we decided to go vertical wings for this competition, and we felt that they worked pretty well, but we kind of ran out of room, so we decided to attach the pistons to the intake. And as you can kind of guess, this caused some problems where if our wings are down, and we move the intake up, the wings will they'll pull up, which would cause problems with pushing large amounts of tri-balls over the barrier. But for just pushing them to the goal, they worked fine. For clearing the match builder bar during autonomous, they worked fine. Yeah, but we'll probably change them just to be a little bit more consistent in all use cases. Here, on the same side as our wings, we have our low hang. This never worked. It was super inconsistent. A robot would always just kind of slide over. I don't know if it was a problem with this bar or if it was a problem with just how our drivetrain is set up. But next time, we'll probably won't be using this to hang. We'll probably be using our lift. Now, speaking of our lift, we can come to our lift. So here we're using a 2-piston lift. We have 1 piston on this side and the other piston over here. We used to have a PTO come from the drivetrain, but we found it was just way too heavy and inconsistent to where it warrant its use. We can see it's a double reverse 4-bar. Sorry, double reverse 4-bar. You can see here so when the pistons push it up, these rubber bands here, they help it to come up, and then these gears here kind of pull the flywheel just a little bit higher. This definitely helps with getting over blockers, but I think we could make it this around the same height by just making a longer lift and not using a double reverse 4-bar, because the amount of weight that those gears and this high strength axle keeping it up added was just not worth the slightly extra height. Now for a flywheel, we have a 32 to 6 tooth sprocket chain. Let's see if I can get a better angle. Yeah, there. You can kind of see it there. And then we have 1.5 motors powering it. So how it works is we have a blue motor here powering directly into the flywheel, and then a 1/2 watt motor here that powers this 36 tooth into 12 tooth to speed up to the same speed as the blue motor, and then both of those go into the flywheel. Now, our flywheel kind of looks like it's 2 different flywheels, and the reason for that is we had kind of a rule confusion where we thought we could use 2 tri-balls at the same time we could hold 2 tri-balls at the same time of the field. So our plan during match loads were to kind of drop them super quickly one onto the other, like boom boom, boom boom, boom boom, and that it worked well, but it turns out that was illegal because you can only have 1 tri-ball over the field at a time. So in our next design, we'll probably shrink the flywheel a little bit, just because we don't need those extra weights anymore. But overall, the flywheel worked well, but because a lot of people were now switching to bowling instead of match loads, we didn't use it too much, and most of our use came from the intake. Let's see, anything else? Let's see, our solenoids are also attached to our intake. I think it was a good decision, but it kind of led to they were also kind of exposed and broke in. They're actually a trip there, so we had to replace those really quickly before our very first match. Yeah, so overall, we didn't do too great. Most of it, as I said, was due to our brain just being broken, but we didn't know it was the brain being broken. But then also our strategy, we were super out of date on strategy because of this new bowling that everyone was doing. We really caught on to that late. And which is good that we know it now, because actually our drivetrain setup and intake setup really fit with it, because once we did learn it near our last few matches, we were really able to super effectively use it to sneak in a couple extra wins. Unfortunately, we did not make it to eliminations, but I think if we had done it again with the knowledge of bowling, I think we could have gotten a little higher. In our future designs, I think we'll make changes with our blade placement and moving our intake a little bit lower so that it just uses less metal and also hits the lift less. As you can see, sometimes it kind of hits there, and we have to always bend it back before a match. Yeah, and then obviously our wings, we'll try to make those a little bit more consistent. We really liked how Ace had their vertical wings at the competition, so we'll try to do something similar to that. Well, we want to keep them on the front, but if that's not possible, then I guess we'll move them to the back on the opposite side of the intake. And yeah, I think that's about it. See you at, I think our next competition is Bellingham Robo Bash, so see you all there.